Hi, this is Jim Montague, Executive Editor of Control Magazine and ControlGlobal.com, and this is the third in our new Control Amplified podcast series. In these recordings, we're talking with different experts about important topics in the process control and automation field and trying to go beyond our print and online coverage to explore some of the underlying issues affecting users, system integrators, suppliers, and other professionals in these industries. For our third installment, I thought it might be useful to talk again with Peter Zornio, Chief Technology Officer at Emerson Automation Solutions, who provided some much-needed expert commentary and content for my On the Edge cover article in Control's February 2019 issue. Like all of our recent podcast participants, Peter has clued me in about more than a few technical issues over the years and provided clear explanations I could in turn relay to readers. Well, Peter, sorry for the build-up, but thanks for talking to us today.
Always a pleasure talking to you, Jim.
Well, let's get started then. First off, when I interviewed everyone earlier, I asked if edge computing wasn't just distributed control in new clothes, and you mentioned there's been a big vocabulary change related to it. Can you talk about that?
Sure. Fundamentally, actually, we in the automation space have been doing a lot of the concepts that you hear bandied about in the digital transformation and IoT world now. You hear them bandied about as if they're brand new things, where they're things that really we have done, and edge computing is one of those. So fundamentally, when people say edge computing, they mean running an application or software to analyze data close to the source of where the data is generated. And basically, that's exactly what we have done for many years with distributed control and DCS systems and PLCs. So yes, edge computing in some ways to us in automation really is distributed control and new clothes. But it's not unique in being the only thing that I see kind of being relabeled in the bold world of digital transformation. You know, digital twin is one of those terms that's very popular now, and it really is the modeling and that we've been doing in automation for a long time, the idea of having a digital model of something that you can run applications against. You know, people love to use the term AI and ML, and we've been doing a number of things in that space already with things like fuzzy logic. You know, you always hear about algorithms, we always used to talk about algorithms, and now, of course, that term has been swept up in the whole terminology around analytics. So I'm actually somewhat bemused sometimes as to some of the more fun terms that the IT world and the general digital transformation world has come up with for things that we've actually been doing in the automation space for a long time.
Cool. Is there any, I guess maybe like a phrase book we should have? If we hear some of the new terms, we might want to think about what the old term might be. Was there any other one?
Well, those are just some of the big ones I think that come to my mind right now, are those 3 or 4.
Okay. Well, usually reporting, gives me a better understanding of my topics. However, this time the definition of edge seemed to get more hazy as I went along. Edge means you're not in the center, implies you maybe could fall off, but I don't think that the numbers and the microprocessors really care where they do the crunching, so why should users?
Yeah, that's a good point. And, again, edge, I think, is one of those terms that were invented as we started talking about IoT and digital transformation. And to me, it was a term invented by the IT folks who knew about data centers, knew about cloud computing, but this idea of actually pushing computing down to where data was being generated was a new idea to them. And so because it wasn't, centralized and it wasn't in the cloud, they came up with this idea, well, it's happening at the edge. It's happening, down where the data is being generated and at the first step in the whole internet transference of the data forward. Now, as far as why users should care, there really is, a lot of this discussion between edge and cloud and whatever is sometimes talked about like there's a winner and a loser. Well, in reality, both have a very important role to play. And in a typical architecture, both are going to coexist, and both will continue to coexist well into the future because they have certain advantages compared to the other computing approach and alternative.
So then, once we get enough participants on the same page, phrase-wise and concept-wise about the edge, what are the advantages of edge computing, and what might, drive me to go and select edge computing for my particular application?
So edge computing, basically means that you don't have to go through the transmission of your data to some application over the internet, okay? So there's a lot of particular benefits that bring. Obviously, many times you don't have the bandwidth to send all the data to some remote computing resource. Security, a lot of people feel better from a security point of view when data is retained locally and results are generated locally. Robustness and reliability, there's no dependency on internet or communication to the cloud. If you have something that requires an extremely fast execution or fast sampling rate, it's better to sit there and run it at the edge, as we would say, where the data is being generated, rather than push it to a remote computing resource at some place. But then there's other things that would favor moving to more of a data center or a cloud type model. You get a lot more compute power available to you typically. For sure in the cloud you do. The cost of that compute power is less when you're not running it at the edge. When you send something to a data center or cloud, you may have a much larger data set, or be able to reach out and pull in other data sets or other examples and look at a problem in a much broader context. And of course, if you're actually running the application in a data center or cloud, it's probably easier to distribute the results and make the visualization and the access to those results easier on a host of different kind of devices, because that's really one of the big things cloud does provide, is universal access to the results. So again, it really depends on the application you're doing as to whether you're likely to do it on the edge or in a data center or in the cloud. But again, it's not like there's one right answer. It's like asking whether I should have a sports car or a pickup truck. It depends on what you're trying to do.
Would there be any typical application that would benefit more from the edge, or ones that might not? I mean,
yeah. So again, what we see is probably the data latency, something that needs to be there close to the data and execute close. Or in automation, a lot of the industries we serve are very remote and don't have reliable internet connection. So those tend to be applications that we're more likely to run at the edge than to push somewhere else to be executed.
Right. So you kind of have to look where you're at and evaluate, as is the case with practically every automation and control project, of course.
Oh, well, right. Exactly. There are different technologies fit different application scenarios.
All right. So now that folks are convinced, and what are some of the best practices that they should consider, or snags that could get in the way related to edge computing?
Well, security is one of the things that comes up over and over again, and that tends to favor edge. But if you're actually looking to distribute the results of edge computing out to a lot of users, you have to have a secure architecture as to how you're going to do that. So a lot of the times what we find is, edge computing applications are great when people want to look at the data in a rather constrained environment, like maybe just on the shop floor. But then when you want to get those results out to other people in other locations, maybe over the internet this time or on mobile devices, you really need to think about what your architecture is going to be for how you distribute the results out from edge computing. The actual horsepower is always a big deal, right? The particular application you're doing has to be something that fits the horsepower you've got in your edge device, and the edge device can be sometimes very limited in compute power because of power, actual power consumption constraints from the standpoint of the heat that generates, or just the physical, form factor. A smart watch is an edge computing device, right? And you're not going to, and by definition, because it's running off a small battery that's rechargeable, it has a very limited amount of compute horsepower that it can do. You're not going to give it, some big multivariable matrix problem to go solve, because that's something that by definition is better off sending to something like a data center or the cloud.
Well, the thing I always, follow up with and end up our podcast with is, and in this case, is how do you think edge computing is likely to continue evolving in the future?
So as I mentioned, really when you look at application architecture, both cloud and edge have a very strong role to play. And what we're seeing is architectures that are involving that kind of blend those two together and enable you to use whichever technique is best suited for what you're trying to do, but also have them mesh together seamlessly. So a lot of the IoT architectures, for instance, the big cloud guys are developing, like Amazon or Microsoft, what they're doing is making sure that a subset of the services that they provide in their cloud computing environment are able to be, or are accessible and available to you to run down at the edge in a less horsepower type of environment so that you can write an application but run it in either place. There's a lot of people investing in new software architectures and data integration structures for edge computing. And there's companies that have arisen, a lot of startups that are specifically targeting creating like analytics environments and other advanced features that can run in the more constrained compute environment that you would find down there in the edge. And then, one of the technologies that edge computing is taking advantage of tremendously right now is this whole idea of containers and containerized applications. You probably heard some of that as you talk to different people about edge, and this idea that you can partition your application into containers. And then you could also have the freedom of saying, hey, if I've got enough horsepower to run what I'm trying to do with the data set size I have in the edge, I can run my container down the edge, but then I can pick that same container up and run it in the cloud on a bigger horsepower environment with a much larger data set. So this is probably one of the most, I would say, developing areas of computer software and computing architectures right now, is people figuring out how do we distribute these applications between the edge and the cloud? How do we make sure that we can seamlessly kind of pick where we run it and make sure that people have access to the results no matter which place it's being executed?
Yeah. Well, batteries are going to get better, and the smart watches and other edge devices, as they've done in the past, are just going to get more capable. So that'll keep that, decision pretty fluid, I would guess, right?
Yeah, it's true. Now, also, in our space, typically when you talk automation, you talk to a manufacturer, they're going to think of kind of anything that they're running in the plant, or even potentially just in the control room of the plant, or in their automation architecture. They're going to think of that as being the edge. So that actually means it can be a pretty high horsepower device. I mean, it can be a workstation or a server, that has a lot of compute horsepower. It's when we start talking about these really big analytics applications and crunching data from multiple potential databases or sources that, are really driving people more to think about the cloud. So, yeah, edge can be really small, like a watch, as I used as an example, but in our space, edge can also be a fairly high horsepower type of device, like a controller and a DCS or a PLC.
Okay, well, Peter, those were some great insights as usual, and I, for one, can say that I feel less edgy, quote unquote, and I feel like I understand it better, and I'm more optimistic about it. Thanks for talking to us today. Okay,
great. So could I say you're less cloudy about the edge?
Well, I may be less cloudy, but I'm not sure if I'm less foggy, which here's another topic to explore.
Yeah, that's a specialization on edge that we probably don't have the time to get into today.
We'll wait for spring as well. All right. This has been another Control Amplified podcast. I'm Jim Montague. Thanks for listening. And and by the way, please remember that Control Amplified podcasts are available at the iTunes Store and at Google Play Podcasts. Plus, you can also just go to controlglobal.com and listen there too. All right. Thanks very much.